Okay.
Yeah. Also, Facebook.
Mm-hmm.
Well, I talked with the recruiter a couple of days ago, and then they are
Mm-hmm.
finding a team for me. But yeah, so but even they can find a team for me, I'm not sure because again, I'm still preparing.
Mm-hmm.
Yeah.
It's better to be like prepare and then give when you're confident. I think, yeah. Yeah.
Yeah. Yeah. Exactly.
Okay.
Okay.
Let's
I think this
start it.
is your problem. Let's get started.
Yeah, yeah. Yeah, this one is for me. I'll go ahead and read the question. Let's keep 30 minutes
Hmm.
each for each.
Yep.
Okay. Give a 2D array input matrix of integers. Create a function spiral copy that copies input matrix values in a 1D array in a spiral order clockwise. Your function then should return the array. Analyze the time and space complexity of your solution. Okay. Okay. It's a little tricky. So, yeah, one second. So the question says I'll be given a matrix. It's a 2D matrix and it can be any, like it's not necessarily the square matrix, it can be anything. Nothing said about that. And then
Yep.
it has integer values. Okay. And then there are some constraints which says number of rows is less than 100 and number of columns are also less than 100 and greater than 1. So I'm guaranteed that there is at least one row, one column. And then I have to read this matrix in a spiral manner and add my uh, add each element to a array and return that array. So it's mostly about I have to figure out how I will traverse this matrix in a spiral manner. Okay. Hmm. So the first thought which is coming to my mind is I know how many elements are there in the array in the matrix overall. Say there are n rows and then there are n columns. So total uh, integers are n rows and n columns. This into this.
Yes.
So
Hmm.
this is what I have to traverse, and what I can do is I can start with zero row, keep incrementing the columns. When I reach at the end, start with that and keep incrementing, then decrementing, then decrementing. Okay. Tricky. That's like one approach. Uh, till I reach the end. Okay. Okay. My boundaries keep shrinking. That's like one approach. What else? Yeah. So then I will have uh, a while loop initially or till total integers. Let's say. Then I have a left boundary for my column values, and then I'll have a right boundary for my column values. Similarly, I'll have a left bottom top boundary for my row values and uh, bottom boundary for my row values. So what I do is I start. So this is where I start. Then I start with say left boundary of column value, and then I go from okay no the other way around. I start with top row, and then I go from uh, left column to right column. Okay, and then I decrement, or I can increment my uh, uh, top boundary. Then what I should do is then I'll keep my top row and then le- little tricky. Mhm. And I did it. So what I'll do is I'll start writing the code because little tricky. So what I'll do is in the code only I'll try to debug if there are any issues.
Oh, okay, what I mean, what's your thinking process? I mean, how would you let's say if this is on a piece of paper, how would you do it?
Yeah. So my thinking process is left to right, right to bottom, then
Yeah.
bottom to left, and then left to top. That's how like I have to go around, but my boundaries are shrinking every time.
Okay. Okay. That seems like a right way to go. Yeah. So basically, you going, and then you going that cycle you just mentioned, right? And then
Yeah.
each time when you finish the complete cycle, and then you decrease the boundary by one.
Yes.
Okay. Yeah. That sounds like a good approach to go. And also, before we code, can you describe your time and space constraint?
Sure. Sure. So this is the time complexity is so I traverse each element only once. So if my matrix is of size m cross n, okay, so the time complexity of order of m cross n, and space is again m cross n because my uh, the space is corresponding to the array which I am populating as a result. So that's again m cross n.
So the space is the one that you're gonna return at the end, actually.
That I will come again, please.
Yeah. So the space this space comes from the array that you're gonna return at the end.
Yes, return. Yes, exactly.
Okay, okay, that's good. Yeah, yeah, yeah. I think on a piece of paper, your thinking process is valid. So yeah, if you want to code it up and then try to shake your code, yeah, feel free to do.
Sure, sure. Okay. Mm-hmm. So, okay, let me define these numbers.
Can you talk while you code?
Oh, sure. So what I'm trying is, sorry, yeah. So,
Yeah, no
I'll
worries.
just uh, so this is my left boundary, right boundary, top boundary, bottom boundary, and I'm initializing it with uh, zero number of rows and zero number of columns.
Hang
And
on. Would you do number of rows minus one, or would you go n number of rows?
uh, so in my code, I was like planning to do a less than always. So,
Okay.
but if I do less than or equal to, I can initialize by minus one.
Okay. Okay. Cool.
Then now I have a bottom boundary is greater than top boundary. Okay. Mhm.
Okay. That sounds like a good
Now
approach.
I'll say while I go from uh, say first I have to traverse row, column, row, column. So it's little worse, but yeah, I'll have say uh, four while loops. So first I'll go by mm for I in range. Uh, so right left boundary to right boundary. Okay, and then I have a result, and then I say input matrix dot append. Uh, so I'm going from left boundary to right boundary. So sorry, result dot append, and then input matrix of. Uh, so my row remains constant, which is my top boundary, and then I increase the left boundary. Okay, then for uh, I'll take a same range, left boundary, right boundary, then I go from top boundary to bottom boundary, and
Yeah,
then I
you're doing
say
really good.
and then I say uh, I goes here, mm, and then I have my uh, right boundary here. Now this is where the problem is, because this will give out of index. Hmm. This will give out of index. So let me for now keep it minus one. Hmm. The top is covered, the right one is covered. Now I go back for I in range. Now this is basically opposite, right boundary minus one to left boundary minus one, and do a steps of minus one. Uh, result dot append. What I should do is input matrix. Here I'll have bottom boundary, and then I, and then the last loop. Just I'm copying it. Let me not copy. For I in range. Hmm. Uh,
Question for you: Why do you have to do this left boundary minus one in this block? Basically, you only lose one, right? You lose the well, you lose the right boundary. This is, I get it, but how come you have to do the left minus one as well?
So the range function uh, excludes. So there are two arguments a b in the left range function. So the range goes from a, starts with a is inclusive, and the b argument is exclusive. Like it stops just before b argument. So my left boundary is 0. Okay, so I want to go till 0, and that's why I have given -1. So
Okay.
it goes till 0. So if we
Okay.
say
Yeah, as long as you cover the one that in the most left one, and I'm good.
yeah, uh, this I can do it in a little pretty way. Like I can just say n minus. That should also work. So similarly, uh, like this, uh, here I can say uh, number of calls minus I. So what will happen is when left is 0, uh, yeah, +1. So it is 0. So number of calls is say 3. So I'll start with 2, and then when I goes to 1, yeah, this is better. So now I want to do this here also. uh, I can say number of rows -1, and this is left boundary. Okay, so top boundary to bottom boundary. mm, Confusing to me. Mhm. Now I have to decrement these things, so the counters, and then go in a loop. So how I update is after one round, but here I have to update it before only. Okay, and then,
Yeah,
uh,
you definitely on the right track. Let me give you a bit of hint.
sure.
You're doing absolutely the correct thing,
uh,
but just you like to take a small jump to the get to the right position, because as you notice, I think you kind of you realize already each time when you have to shrink after each of the traversal of the along each either like a row or the column, right? And then you
mhm,
shrink a little bit. So the way that I would do it, right? After each one, some of the for loops,
mhm,
for the one that you know, I mean, for most, I think for all of them, you know
mhm,
that you have to shrink a little bit until, I mean, and then there's some if statement to check
mhm.
a condition where if that is too small, you cannot do it no more.
So after every for loop, I have to decrement and check.
Exact.
Yeah.
Yeah. After each of the for loop, you need to shrink a little bit on the bound,
Hmm.
right? And then for some of them, you have to check, right? If that's still,
Hmm.
um,
Yeah.
but you're definitely on the right track.
Hmm. A little tricky here, so that's what I'm thinking. So after my first for loop is 1 to 5 in the given problem, and then the second for loop is 5 to 20. But at 5, I can't shrink any boundaries. Uh, okay, let me use pen paper, and then maybe I'll be able to quickly find it. Is it fine? 2 minutes.
Yeah,
Yeah.
it'll be okay.
Yeah. Okay. So 0, 0.
Give me 1 sec. I will back right with you. Give me 1 sec.
Sure. No.
Yeah, I'm back with you.
Okay. Hmm. So here I can say right boundary minus equal 1. Okay. Here I can say bottom boundary minus equal 1. But I have to go from left to right. To
Yeah,
go.
yeah, you're doing something really like on the right track. But would you want to do before this for loop or after this for loop though? This right boundary decrement.
Hmm. Left boundary, right boundary. This is fine. This after every, so this for loop is done, right? So I'm trying to because I this decrement is for this for loop,
Okay,
and
okay,
this decrement is for this for loop. Uh,
okay.
but there is one corner case I'll be missing. Uh, so the boundary plus equal to 1, and then this will be uh, top boundary plus equal to 1. Now the problem is I can do actually I can so the problem will be from here. Let me take an example. So I should have a just if I have a 2 cross 2, I should have 0 0 0 1. 2 cross 2 means 0 0 0 1 1 1, and then 1 0 is right. So uh, I start with a number of rows and number of columns is 2 and number of columns is 2, and left and right boundaries, left boundary is 0 and then right boundary is 2. Then I have top boundary is 0 and then bottom boundary is 2. This is where I'm starting with. Then when I have my, so these conditions are true, and so my first for loop is from range 0 to 2, and what I'm doing is my input array is this. So it's basically, it will do uh, top is 0, and then I is 0, other one is okay, 0 0, and top is again 0, and then I incremented to 1. Okay, so this for loop, first for loop is done in this, and these are my outputs. Now I go to RB minus equal to 1, which means these four values uh, is 1. Okay. uh, Now I have 5 minutes, right? Yeah. Okay.
Mm-hmm.
I'll just, yeah. uh,
You're doing
Here,
great.
uh, so here I have input matrix, and then my I goes from 0 to 2 again, because I have not incremented top boundary and bottom boundary. So RB RB is 1. So RB is 1, and 1 minus 1 becomes 0. And that is the problem. I have to keep it like this. So now my RB is 1, and I goes from 0 1. So it becomes 0. Sorry, it goes from, yeah, 0 to 2. So it goes 0. No, that's the problem. So it goes from my expected output is uh, after 0 0 0 1, I want 1 1. My RB is 1, but my I, oh, oh, but my I, okay, sorry. Uh, my I here has to be number of rows. Number of rows minus I. Okay. So first, when I is 0, number of rows is 2. So, and then plus 1. A number of rows 0 0 minus 1 2. So yeah, it becomes 1 1. And then when I becomes 1, it becomes, when I becomes 1, number of rows minus 1 is 1, and 1 plus 1. Mm, how 2 minus 1 is 1. To start with, I need this minus, yeah. Now it, okay, this is small trouble. 2 minus 0, and 2 minus 0 minus 1, and then I want it 2 minus 1 minus 1, 2 minus, this is correct, yeah. So I basically get 2 minus 1 is 1, and again minus 1, so it will be 0, and RB is 1. Okay, so this is fine. So similarly, I have to fix these. Similarly, I have to fix these. IB number of columns minus 1 minus 1, and then TB IB. Okay, and
Give me 1 sec. There's some delivery guy. I'll come
sure,
back to
sure.
you. Yeah. Oh, thank you. Thank you.
So I'm trying to run my code now. Hello.
Hello,
I'm
hello.
trying to, yeah, I'm trying to run my code now.
Okay.
Uh, there is a indentation error, which I think is common in this Pramp. I just fixed the indentation error somewhere. I have faced this. Do you also face this?
Um,
Sometimes it's.
some people they do, yeah.
I get it.
But I think you get I would say like 80 or 90% correct. Like I would say 95 even. This is very
Okay.
close to the official solution. So mm,
Okay. I think it's not 100% correct. I'm not able to. Yeah. One sec. Yeah. Now I'm just copying the solution, which I have fixed it on some separate editor. Okay. Just I'll just paste it here.
okay.
Okay. It has executed. It's failing. Mm-hmm.
Well, I think the thing is for these two cases,
Mm-hmm.
uh, I must say you get 95% correct. But for these two cases, you might have to check. I have to check the condition.
Yeah.
If the top row is so when will we execute this one? It's gonna be the bottom. I mean, if the bottom row is greater than or equal to the top row, and then we will do this.
Right. Right. So uh, what I can do is what I was
Yeah,
expecting.
exactly.
I
Yep.
can, but see if say let's take. Can I put some print statements here? Fine.
Oh yeah, for sure. If you, that helps you.
Yeah. So I'll just put. I'll print all these four values. Uh,
Yeah, but I wouldn't recommend in the real interview though. If you are doing
yeah,
real
that's
interview.
correct. Yeah. Yeah. So you're
But
saying
this is
put.
not easy. Yeah, this is not easy.
Yeah. So, see, it says 0000, right? Because in this one, so it will not go in this for loop is what I was expecting, and that's why I was not checking. So it says 0000 and okay, actual is so instead of one I'm getting one here. Instead of one I'm getting one. Uh, okay, okay. Uh, why will it be one? So to start with, I will have 0101. Yeah, and then okay, I can do this. I can check here. If not of this and this, and that's where I break. Yeah, and yeah, I have to do it for all, but that's like one. Yeah. So this condition Has to be there everywhere. Hmm. It's okay. I think, yeah. I mean, I've not done well here, but yeah, it's time, so we can switch. I'll try to do it plain.
Yeah, but I think you get the main idea, correct? Just some
Yeah.
checking. Yeah,
Is
yeah.
it
In,
like the
yeah,
correct idea, or is it is there a like better or a cleaner way here
mm,
instead
honestly,
of yeah?
yeah, it's not entirely. It's not a lot cleaner. I mean, facial solution.
Okay.
Uh, this is certainly. I mean, when I was trying it, when I was trying it for the first time, I had a difficulties. I struggle a lot with this one as well. The way that, but I can walk through with you the way that I solve it myself. Okay,
Sure. Sure. Yeah.
I certainly didn't follow the official solution. So my
Hmm.
thinking process was, I know that it's gonna go to the direction. It's gonna go to in the rows first, and from the left to the right, and then to from the top to the bottom, and then to the right to the left, and then go up again. So I know it's like this is like some sort of like a cycle, right? This is like a cycle. But
Hmm.
the problem is, when do we know that we're gonna change the direction? Right? It's keep going that direction, and then hit something, and then it
Hmm.
going down, and hit something, and then it change direction, hit something, right?
Hmm.
So the way that I solved it myself was either is hitting the boundary, and then hit that boundary in change direction, or you hitting something you have seen before.
Hmm.
Yeah, so that's the way that I solved it. But your
Hmm.
solution is fine. Your solution is maybe it's very close to the official solution.
Okay. Got it.
But the official solution has a little bit more checking, like if statement checking to make sure that it's within bound or not. That's exactly what you're doing.
Okay.
So when you narrow down all the conditions, and then you get exactly what the solution gets. But also I told you the way that I solved it.
Got it. Got it. So you were after each point checking whether I hit the boundary or I have some like I have seen this element before, right?
Yeah, exactly. Yeah, there are two reasons you want to change direction.
Hmm.
One reason is the you hit the boundary, the wall, the
Hmm.
wall. Second reason is you hit something you have seen before, and then basically you keep going, toot, and then you hit it. Oh, you change it, toot, 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 and toot, and then hit something, toot, 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 and then hit something, and then you change direction. That's the way I solved it.
But how do you like measure? How do you keep track of the elements which you have already seen?
Good question. So I use a scene set.
Ah, okay.
So I use a bit more space actually.
Yeah, got it.
Yeah, but for your approach, you save a bit of space. That's gonna be, I mean, strictly speaking, you're doing like a big old one, right?
Yeah, yeah,
For space. Yeah, yeah.
got it. Got it. Perfect. We can swap. Yeah.
Okay, sounds good. Let's see what I got. Shortest word added path. So given two words, source and target, and the list of word. Oh, okay. From the source. Wow. Okay. So okay, I have the source word I'm given is bit. Target is dog. So I'm gonna go in this explanation. It's gonna be go bit, but put. So I'm changing one character at a time, right? So bit change to but, which is change the I to the U, and then B to the P. Okay, put and pot. Okay, pong. dog, and off the word. Okay, and then from no to go. Okay. There's some constraint. The length of the word. Okay, and okay. Also number word. Okay. Um. Yeah, I need to return the shortest path. Let me think. Okay. This is like a path finding problem. Path finding. Let me think. Interesting. So I can only swap one letter at a time.
Yes.
Yeah, almost thinking something like this. So let's say I started with bit, and where can I go with bit, right? So I can go with but, or I can go with big, right?
Yes.
That and then that's about it. And then from but, where can I go with but? I can go well put,
Mm.
or I can go um yeah, that's it, right?
That's
That's
it. No,
only
pot. We can.
yeah, okay, yeah. Which one? Pot?
No, pot is wrong. Sorry.
Yeah, I can go with but. And from
Yeah.
big, where can I go with big? I can go with yeah, I have nowhere to go with big, right? And with
Yes.
put,
Yes.
so that's actually that's the dead end.
Hmm.
And with put, well, I can, based on the example I'm given, I can go pot, yeah, pot after, right?
Mm.
And then I can, well, put, and also yeah, that's it.
Mm.
Yeah, and then the rest is just go to that path. Okay, so it looks like and then I keep searching for, I mean, swapping one letter at a time, and just keep searching for the destination. So this looks like a I don't know, maybe we can do it like recursively, and then keep changing one at a time, and to see if that the new letter is that, I mean, is that in the given set or not.
Right.
So okay, if you're, so do you agree this is gonna be like a recursion problem?
Yeah. So, like as you mentioned, we have to do a searching, right? And yeah, this. So it can be solved iteratively or recursively, but yeah, the main thing is how will you search? Like, uh, can you double click on that? Like, can you concretize on the steps of searching?
Yeah, that's good question. So I can only change one letter at a time. And then, for example, from bit, how can I go to but and also go to big,
Yeah.
right? So what I know is that I can change one letter
Hmm.
only. So that means, I mean, even before looking at the set, right? So what I know is that from bit, I know it's gonna be something looks like I put a star with a represent some potential
Surely.
letter, right? I can go something bit, and then also go something like a B, B something T, or I
Yeah.
can go something like BI something. So this is,
Right.
yeah, that's three things I can try, right?
Mm-hmm.
And then within this within, so I have like a 26 possibilities, right? So like this is
Correct.
um and so if that's the case, for each of the try, it's gonna be
Mm.
um the length of the word, right, times
Yeah.
uh um uh the length times 26 essentially.
Yes.
and and then I just keep trying to see if they are in the in the set or not.
Okay. But so if you say from bit you went to but, and then from but you went to put, right? Now from put you can again go back to but, right? I mean, if you
Okay,
search,
okay, yeah, that's a good question. How can I prevent going back, right? That's your question.
yeah, I mean, yeah, how will you like not go back and like get stuck in a loop? How will you
What I can
prevent that?
do is, yeah, what I can do is just kick out that word from so for example, yeah, in but I can just
Hmm.
remove the whole thing.
Okay, so then what is the complexity, like maximum big O time complexity?
uh Good question. So I can change one letter at a time. So I kind of, so this is the length of the word. That's the
Yeah,
number of characters times
yeah,
26.
yeah.
And yeah, it depends on how many tries I have to do. Just this is how many tries for each of the uh,
So this operation, length of words in word into 26, how many times will you do, like max?
max will be the number of words possible.
Exactly. So it's basically bounded by uh, uh, the length of
Yeah,
uh, words array into.
exactly. Yeah. So, oh, okay. To be more concrete, will be something looks like this times length of a word.
Correct. Yeah. So yeah, that's the time complexity. Yes. Max.
Okay. Do you think I'm good to try? Good to code now?
Sure. Yeah. Yeah.
Okay. Thank you. So as I mentioned, it's gonna be recursion. I'm gonna call it rack, and what I'm gonna given. So given something, I need to fill out something. I
Mhm.
put an X in here. I made something to do,
Mhm.
and um, for recursion, I need first thing I have to do the exit condition, right? So if um, well, if the word that if let's say a word, if the a word is equal to the target, I'm gonna return the result. I'm gonna initiate the result as 0, and then okay, maybe yeah. From here, I already kind of know that I need to give a word to
Mhm.
recursively find. So if the word is exactly the same as target, I'm done. And and now I can do the searching, and where I'm gonna do one letter at a time. So let me think. So yeah, so this is what I'm gonna do. So um, for yeah, so for letter in a word that is given, um, So okay, so also for a substitution in well let's say in A, B, C, something like that, right? So this is something I can swap, right? And this is
Okay.
gonna be 26 letters.
Mm-hmm.
Okay, for that range, I'm gonna put a colon in here, and then this is a substitution, and um, it's gonna be a sub, and plus, well, I think it's easier to do a enumerate and sub plus a word. This is where I'm doing the swapping. Okay. Um, hang on. If that letter is in the middle, okay. If that letter is in the middle, how can I swap it out? Well, I can do something like this. I think it's maybe easier. I convert to a list. Yeah, I think this probably a little bit easier. It will be uh, I'm gonna call it a word list. Looks like something like this. So yeah, here this is where I'm gonna do the swapping, and in that I is equal to sub, and then I'm gonna so I'm gonna change it back to a string. Dot join. But hold on, I might change it. Okay, yeah. So what I'm gonna do is I'm gonna make a copy of it first. So I'm gonna call it
Mm-hmm.
temp. So I don't change the master,
Mm-hmm.
and then the temp at the ith index, and then swap it. I mean, substitute it with the sub either like A, B, C, and D, something like that, and then I put this one and translate it back to a string, and then I call it rec. Maybe I call it temp string equal to something. So now I have something I haven't done. So which is I haven't checked the thing is in the word set or
Yeah.
not. So
Yeah.
the first thing I'm gonna do, actually, I'm gonna convert this thing to be a set. It's easier to manage. It's also a lot faster.
Okay.
So I'm gonna convert to the set. Okay. So first thing to do is to well, obviously it's gonna be checking, right? It's gonna be checking. Yeah, checking. So if this one is in the words, I can recursively call the guy. Oops.
Okay.
Yeah, am I on the right direction?
So the thing is like the same problem. You if you go from but to put, and then you'll again go from put to but, and then put but to put. It will be like a infinite.
Right. Oh yeah. That's a good reminder. Yeah. So yeah, that's very correct. And
And also
um,
one more like check is if L and sub are equal, then you don't want to do it.
which one again?
So line number 9, the L, and the line number 10 sub. If they are same, then you skip basically. Then you don't want to
Okay,
call it.
yeah, exactly. So if L is equal to sub, I'm gonna continue.
Sure.
So a few things. Um, so let's say if the exploration comes to big, and then if I remove it from the set, so that prevents
Mhm.
the future comes back. I mean, the future exploration comes back to the word big as well, right?
Mhm.
So I'm not sure if I want to like completely remove it. So let me see. Let me think. So
So the idea is to do a breadth first search here. Okay, so you know the concept of breadth first search. So what we
yeah.
do is we have a node and then we have childs. So we explore like all the childs and then we go to the next childs, right? Similar is like the childs are all the variations possible, and then we are basically searching the childs in the words array till we reach a target. uh, and the key thing is you have to have a visited uh, uh, some visited array here, so that you, like, if you don't go, if you say went from but to put, and then you again don't go back to from put to but. So because like we have to always move forward, so that's how we'll reach target. So if we have explored but, and that's how we came to put, so we will not, should not go again back to but. We should like explore the all the possibilities of put apart from but.
Okay. You talking about a BFS approach. I think probably maybe
Yeah,
easier to do like a iterative approach. So I
yeah,
think I need a queue. A
yeah,
queue, it is a started with the source,
yep, yep,
and while queue, and
yep.
I can reuse a lot of word while queue. So a word equal to queue dot pop to the left.
All right.
Okay, and then I'm gonna change the thing to a list to work with exactly that.
Mm-hmm.
A word list equal to change to the word. Okay, and then now I'm gonna reuse some of the word that I've already written.
Yeah.
And also, as you mentioned, I need to have a visited
Yes.
visited equal to a set. So I don't go
Yes.
back. I don't go back. Okay. So
Yeah.
for
Yeah.
I in L, okay. So and then I'm gonna reuse this part as well. I can reuse a lot of this word, but it's just some modification.
Yes.
So yeah, so if the thing is the same, I don't have to do and then skip the next substitution. So for the temp, it's gonna be make a copy of it, and then the temp is equal, make the substitution. Yeah, so in here, this is where I'm gonna go back. So if and oops and not the temp string is not in the visited,
Mm-hmm.
and it's not gonna be recursion. It's gonna be q dot append
Mm.
the temp string that we are talking about.
Perfect. Yeah.
Okay, and also I have the exit condition, right? So
Yeah.
um, so if a word is exactly equal to the target, and then I'm gonna return the result.
So you have to be
And
careful about the result. Like, what is it asking about the result? It is asking, like, how many hops did you take to reach the target?
oh, right. So exactly. So what I'm going to do is I have an additional component, which is step.
Mm-hmm.
Yeah, this is something I'm gonna keep track of. Each one, when I layer out, like go to each layer, I'm gonna increase the step by one. So essentially, that's a good reminder. So I gonna call it a word and also a step and step, and then
Mm-hmm.
actually at the result I'm gonna return a step.
Mm-hmm.
So this is how many steps I have already taken to reach that my goal.
Okay.
And yeah, and also this one's no change. And only thing is going to be changed over here, right? It's going to be a temp string, also the current step plus one. So I move advance one step at a time.
Mm-hmm.
Um, and at the end, yeah, at the end I'm gonna at the end if I don't get hit this guy, I'm gonna return what -1.
Right. Yeah, this looks fine. We can complete that line number 26. I think just have to write till Z, and then the code is executable.
Yeah. Okay. You think you think this is good? I think we can good to end here. I don't want to waste your time
Okay.
and then
Sure.
run
Sure.
it on
Sure.
the code. And yeah,
Yeah,
I mean
this
in
looks
the
good.
real.
Yeah. Uh, the
Mm,
like the thing is the step function variable here uh, changes only when we run a while loop again. So maybe we don't have to maintain it at a element level. We can maintain it at a global level where whenever like in BFS, say when we calculate a depth of a tree, right? We just change when we have explored all the childs. You got my point, right? Or
what
no, that's fine.
can you
I
say
think
that
yeah.
again?
No, that's fine. I think yeah. This looks fine. Yeah, I was thinking little. No, it's fine. It's fine.
Okay. Okay. If you think
Yeah,
this is
that's
fine,
fine.
okay.
Yeah.
Okay. I
Oh,
think yeah.
okay.
If you like it, I think we can leave it out. Leave it at here then.
Yeah, yeah, yeah. It's fine.
Oops. I think let me see. So maybe I can still erase this part, guys, and then
Yeah,
yeah, this is gonna be my final product. Okay. Okay, and yeah, if you like it, and we can leave it in here.
sure, sure. Yeah. Okay.
And can I connect with you on LinkedIn?
Definitely. Yeah. So,
Yeah, I think
where are
I
you
think you're
based
very
out of?
helpful. I'm actually in Canada.
Oh, okay. Cool. Cool.
Yeah, where are you right now?
I'm in Bangalore, India.
Okay, nice.
Yeah.
I've never been to India in my life.
Yeah. Let's connect. I'll I'll send you a request. Let me see if I have
So
permission.
so you in the beginning you mentioned you're interviewing Google and Facebook, right?
Yes. Yes.
Okay.
I'm right now working with Flipkart, which is a e-commerce company in India like Amazon, and it's like a leading e-commerce company, a very good competition to e-commerce. Sorry, Amazon. So I'm not able to send you a friend request here. I'm not sure. I'll give
Yeah, some of
my
my yeah, you can send you yours, and then I can
yeah.
some people have been complaining about I don't they cannot send me a request as well.
Hmm. So that's mine.
So you are more like a senior engineer, or you I don't think based on your coding skill you are not like a graduate student or something.
No, I'm a graduate student, but I'm into machine learning. I don't code regularly as a software programmer, but for Google and Facebook, you need to do this. So I'm not very well versed with like yeah. I'm mostly using
Oh
libraries. Yeah.
yeah, but by graduate student I mean the student just graduated, not like a master student. I can see that you have a master's degree. Okay.
Yeah.
Well, okay, you're a data scientist. Wow.
Yeah. Exactly. Yeah. Yeah.
So I think for my understanding, data science basically a lot of like a SQL, like a SQL coding.
Exactly. A lot of SQL coding, lot of pandas, NumPy, Spark. Not not a functional code like these. Very little. Yeah.
So the one that you're interviewing is software engineer, right?
It's machine learning engineer, and uh, I'm not sure like what kind of role it will be, but uh, uh, so the boundaries are getting blurred slowly. What's happening is software engineer and machine learning engineer, they are kind of doing the same thing nowadays, and specifically in Google and Facebook, I think they are all coding, but say machine learning engineer is coding more on a ML related products. So let's see. But here, what do we do is like we most of the time are doing exploratory projects, and we get help from engineers to productize our code. Whatever.
Yeah. Okay. You mentioned. Okay. Yeah. Yeah. So to your topic, you mentioned about the crossing over between the two areas.
Yeah.
When I interview with Google, I actually interview with a machine learning engineer from California.
Uh-huh.
So but the role that I was applying, it was a software engineer. So to your point, there are a lot of crossover, obviously.
Yeah.
And you mentioned you're going for Google, right?
Yeah. Yeah.
Yeah, yeah. So I'm not sure you will come across the same engineer that interview me. If you do,
Mm-hmm.
and I can share with you my failure, right? I keep sharing my failure to other my friends so they don't follow my failure. So the one that tripped me off was they asked me to code a iterator, a Python iterator object.
Oh, is it okay?
Yeah, and then and 2 months ago, I didn't know what it was iterator. I was like, are you telling me to code up like a for loop or something? I thought for loop is iteration, and it was like I had a lot of difficulty because I didn't know what it is. Right? How can I code it up?
Exactly.
And he was
Yeah.
like, yeah, iterator, you can do next method. You could keep calling next, and then you go to the next one, right? So, and
Mm.
then he give me like the init function. Yeah, this is your init function. This is your next function. Please
Huh.
code it up. I was so struggled for the entire 45 minutes. I bombed it. So
Okay.
don't be like me. If you so my point I want to convey to all of my friends is that object design is very important. Sometimes we overlooking, we look in like a breadth-first search, look at
Right.
grid like the one that we look at, but object design something that they really like those, especially iterator, something that I was overlooking. I thought I
Uh-huh.
would never use iterator ever in my life, but actually I was get asked, right?
Uh-huh. But how do you
So
like code it? So I think it will be similar for me if I get that question. Uh, so like, how will you code it?
I
Did you
couldn't
find?
code. Yeah,
No,
I couldn't code. So. Mhm.
but like afterwards, did you like look for it? How do we code
Yeah,
it, and
yeah.
what were they
Now I know
expecting?
iterator. Now I know iterator. Now I know generator back and forth, like in my life, in my brain, in here.
Okay.
I did, but I learned it the hard way though. I learned it the very hard way. I hope my friends don't follow my path. They fall in the to the clips that oh the iterator. Yeah.
Okay.
So another question I got asked was even like let's say if we given like a million record of data set, I think you'll come across that every day with your data science, right? So how do you manage your memory efficiently if you're given like a million records, right? A
Hmm.
million records. How do you use Python to manage your reading the data efficiently? When I was interviewed, I couldn't answer because I did not know what was iterator. But I went to YouTube.
Hmm.
So the correct answer was the advantage of iterator versus like a for loop is that iterator only takes one bit of the data at a time.
Mm-hmm. Okay.
Yeah, for example, in like a million records, it only
Uh-huh.
read the top one and then save that top one in the memory. And then when you keep reading, and then you keep cache it to the memory one at a time. So this is where you can manage if like a memory more efficiently with the iterate. I mean that's the main reason why it exists. So I couldn't answer that question. He keep ask always keep out being asked.
But okay, but it's very hard to code it, right? How will you code a iterator? I mean, you know this concept of a iterator, but how will you code it? I'm not sure. Still,
Yeah,
uh,
yeah. So I was asked to code up like a customized iterator.
uh-huh. Okay.
Do some
So this
Google
is
if yeah, do
okay.
some Google, and yeah, if you not sure like me, I had no
Sure.
clue. I had no clue, man. I was like, oh my goodness.
I'll definitely do this now. I think, yeah. Uh, I mean, understanding iterators and generators is one thing, but how to code it is different. So let me, if nothing, I'll reach out to you
Yeah, yeah. You can
on
shoot me a
LinkedIn.
message. And when is
Yeah.
your interview?
So next Tuesday is my interview.
Okay. Well. Good luck. You still have a week, almost a week to prepare.
Yeah, yeah. So basically, next Tuesday is my second round. Uh, in the sense, I completed the screening, and then I have two DS algo rounds and then two machine learning rounds. One DS algo round is over. Second DS algo round is on Tuesday, and post that I'll have my machine learning rounds.
What was the most challenging question you came across? Or areas if you're not allowed to disclose. I mean, up to you. If you don't want to disclose, it's fine. I just want
No,
to
no.
learn.
So I was, I think, lucky compared to you. So yeah, I got this question in the first screening round was basically, yeah, he said like it was machine learning related question in the sense. Let me think about it. Yeah, yeah. So you have some uh, data points on a number line, okay, and then some of them are labeled as class 1, some of them are labeled as class 0. Okay, you have to come up with a line which basically is like a classifier line. Okay, you have to come up with the optimal classifier line uh, in an order of n.
Oh, so like this is like a logistic regression.
No, no, it sounds like a machine learning question, but it's a DS algo question. So it's like you have say on a number line, okay. So number line is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, assume that, and then so I'll just write. So say 0, 1 belongs to class 1, and then 0, 2 belongs to class 1, and then 0, 5 belongs to class 0, and then 0, 6 belongs to class 0. Okay, now I have to come up with a line uh, or a point, you can say, which bisects these two optimal number. Okay, so the optimal here will be 0, 3, right? uh, does this make sense? So if I go left of this, everything will be class 1. If I go right of this, everything will be class 0.
Okay, so it's like a boundary.
Yeah, I have to come up with a line which and so this is a simpler case, like in the sense I have all the points on the left as class 1, on the right as class 0, but there can be something like 0, 0 is of class 0, and then zeros, say 0, 10 is of class 1. Still my boundary will be this, right? Optimal
So,
boundary.
so why do you need the first dimension? Why do you need the zeros? It always depends on
That,
the second dimension,
yeah,
right?
it's not needed. Yeah, I mean, it was like it can be extended to 2D. So right now it's in 1D, but this problem can go to 2D also. But yeah, the first is not needed. You are right. Just by looking at these, you have to basically come up with this number 03, okay, in order of n. So these are the points given, and we are given the class of these points. I have to come up with this point in order of n.
Okay, maybe the way that I would do it, maybe just see it within the group and then look at maybe the maximum or the the minimum of the entire group, and then come up with, and that lower the minimum number may be the boundary.
No, that's not correct. So that's how you. So basically, you'll have to look for it. So see here, what is the imbalance, class imbalance like? If I put 3 as a boundary, right here, two are correct, one is wrong. Here also two are correct, one is wrong, right? So if I say
Okay,
left
yeah.
of 3, everything is class 1, right of 3, everything is class 0.
Oh, okay. So basically, you keep changing your boundary until you get all the test cases passed.
Yeah, not all test cases, you have to maximize, like minimize your error. So the
Oh,
error
okay.
here, yeah, so see this is given, and base if your class, if your boundary is 3, then the predicted label here will be 1, for this also 1, for this also 1, and the
Yeah.
predicted label
Oh,
for this
okay.
will be 0, 0, and 0, right? So the error is so the error is 2. If my
Yeah.
boundary is 3, if the boundary is 3, right, then the error is 2. Okay, now if I say, if I have a boundary of somewhere this, say 5.5. Okay,
Oh,
so
it's like
the
a binary search.
yeah, so binary search is one solution, but binary search will also be like n log n, right? Because you search and then you calculate error every time.
Yeah. Yeah. You have to sort it. Okay. You have to sort it.
Yeah, so the solution has to be log order of n.
Wow. Okay. Maybe. Wow. This
You
is
can
quite
try. You can
challenging.
try offline. I'll tell you the second question, like which I got in my second round, which was easier, I
Hmm.
think. This, if you don't get, like, you can reach out. So I hope you understood the question.
Yeah.
Okay. The question I got in the second round was, you're given a basically a streaming array. Okay. So I was given a class stream. This was basically an API where I can get next number. Okay, and then is end of stream. This these were the APIs I was given. I had to write print min of last n elements. So I'm getting a stream of elements, and then and then I have to print the min in last two elements. For example, if I get 3, 1, 1, 2, 4, right, and this is the input, and my n is say 2, right, my output should be 1, then 1, right? So among these it is 1, among these it is 1, and then among these it is 1, and then 2. This is my output. got it.
Oh, so like the most recent two in numbers.
Yeah, in the uh, recent n numbers, find the min and output.
Wow, that's really interesting.
So
But you're allowed to
yeah,
use like a cache, right? You're allowed to use like a cache, right?
yeah. You can use cache. You can use any data structure, but you have to optimize on. So for this, the answer has to be like uh, the the time complexity here has to be order of log n. Like uh, for each element in the stream, and if there are s elements, it has to be s log n. And space space also order of space is order of n. If you can come up with a solution for this, and for above question, it is order of n. Order of n is the number of data points I am given. So here it is n 2 3 4 5 6. Here n is equal to 6, right?
Mm. Okay. Wow. This is log. This is a number of elements. S is a number of elements, right? And then log n is what was log n again?
So n. So this is the I'm saying the final answer has this time complexity. Uh, so S here is for the below example. S is 1, 2, 3, 4, 5, and n is 2. You got it.
Oh, okay. Yeah, I got it. Okay. Well, because you're interviewing Amazon, before let you go, because I talked to with another guy who interviewed Amazon, and I can share with
Mhm.
you what he got though. He got
Uh,
a question about a bit manipulations, which he couldn't answer.
uh-huh.
The bit operations, right shift, left shift, or and XOR. So those
Yeah.
yeah, I hate those.
Why do they ask such questions? I don't understand. Why do they
I
ask?
know. It was not used in real life, but he got asked.
Yeah.
So that's one question he got asked.
Okay.
Secondly, he got asked, which was a bit easier. He said, code up a library uh, book like a book borrowing system.
Okay.
Yeah, if you're not familiar with that, go to LeetCode discussion board.
Hmm.
There's a LeetCode discussion board specifically discussing how do you code up a uh, library system. So then you have a librarian, you have a members, and members can borrow books, return books, renew books, right? So that's a object design problem that most people, including myself, overlooked.
Okay. Okay.
Also the iterator. Maybe I can find you the iterator one. Give me one sec on lead
Is
code.
it on lead code?
Uh, it's not exact, but it's kind of similar. Give me one more second.
Sure.
Give me one more second. I can find it for you. Yeah. This one. Yeah. I can give it to you. It's very niche. The problem is very niche. It's not the most popular question ever, but it does get asked.
Okay.
All right then.
So this one, okay. So at least you will know how to code like the pattern, and then maybe we can relate with some other problems also if they ask. It's not a like trivial data structure problem. So yeah. Okay. Okay.
Yeah. Okay.
You
Yeah. Good. Best of luck if I don't see you again. If you want to practice interview again with me, yeah, just send me a message on LinkedIn and then we can connect again.
sure, sure.
And
Definitely.
best of luck to your interview next week. And I hope that you get hired. If you do, please consider referral.
Sure. Definitely. Definitely. We'll connect definitely on LinkedIn. Yep. Yep. Bye.
Yeah.
Bye.
Stay in touch. See you next time.
Bye. Bye.